you have a 1,500 pound or 1,500 kilogram car. That's a mass. And it goes from 0 to 90 kilometers per 1 hour. And that is a velocity. We'll have to do some conversions on that. And then it does it in 5 seconds. And then the final question is, what's the average power? Okay? So remember, power is energy over time. We know the time is 5 seconds, but we got to find the energy. So now to find the energy, is the car in motion? Yep. So, all right, let's think this through. How do we... The average power, I want to... I got to be careful how I word this. Okay, so the average, so it's energy over time, right? So power, right, is going to be work over time is another way to think of it. Work over time, and then work is actually can be like, didn't we say that was delta kinetic energy, right? So we would say delta K over time, all right? And that's what I wanted to be specific on, okay? So power is energy over time or work done over time. Mr. Adams always says energy over time because of the units in joules, and I say it that way because it's easier for you guys to remember, all right? And 90% of the time, I mean, you could do work over time, but we also do energy over time because work is the change in energy, right? So the change in energy, let's do delta K. So delta K is equal to K minus K initial. Well, remember that that is 1/2 times the mass of the final velocity minus 1/2 times the mass times the initial velocity squared, right? So what's the initial velocity though? 0. So this whole thing is 0, right? 0 squared times the mass times all that stuff. So my delta K is actually equal to 1/2 times the mass, which is 1,500, right? Times the velocity, which is 90 kilometers per hour, but I want it in what?
Meters per second.
Meters per second. So before I can plug that in, I need to say 90 kilometers per 1 hour. 1 hour is equal to 3,600 seconds. And then I got to do kilometers to meters. So I'm going to say 1 kilometer is equal to what?
1,000 meters.
1,000 meters. Okay. And then this will cancel with this cancels with this, and I have meters, whoops, I have meters per second. So my answer will be meters per second. All right, let's do this in our handy dandy calculator. So I'm going to say 90 times 1,000, enter, divided by 3,600. 25 meters per second. Oh, that works out good. So this is 25 meters per second. So delta K then is all this stuff. So now let's plug that in our calculator. 0.5 times 1,500 times 25 squared. Is that right? All right, cool. So, wow, that's quite a bit. Like 4.7 joules, roughly. Well, 4.7 times 10 to the 5th, I think. So let's
So that would be 4,685.
so that's the kinetic energy. So let's go back here. I need a little more space. Did somebody write that down while I had it on the screen?
4,68750.
All right, so remember that power is equal to work over time, but we said that's delta K over time, and we said the delta K was what number?
4,68750.
0, right? Joules, all over how many seconds? 5. All right, so that, it looks like I just got to take this number and divide it by 5, right? Boom. And let me double check my notes. Yep. Your textbook rounds using sig figs, so they said that the power is about 9.4 times 10 to the 4th watts. Okay? And then I think, depending on how they worded the question, it says, what is the average power required to do this? And we could say watts. Another way that we could write that is in horsepower. So now, in your textbook, there's a conversion ratio for watts to horsepower. So I could also say that the power is equal to 9.4 times 10 to the 4 watts. And then we have to do this conversion. So look in the front of your textbook. I think it's the front. And so 1 horsepower is equal to 745.7 watts. So 747, I always forget that one. 745.7 watts is equal to 1 horsepower. Okay, so when when people say, oh, my car has 500 horsepower, they're figuring out the work done over time per second. Okay, so that's the conversion. And so then if I take this number and I divide that by, what did I say it was, 745.7? Yep, all right. I get 125 horsepower roughly. All right, and your textbook rounds that using sig figs again, which is power is also approximately 1.3 times 10 to the 2 HP.